All right, I've got the stuff leaving OBS. We apparently exist. We apparently are getting decent bandwidth and have an excellent connection. Cool. All right, let's try this again. Is it going to work from here? Live stream currently offline. Fingers crossed, streaming now. Cool. All right. Let's get back to here. That is fine. Okay. All right, let's go ahead and get this started. Cool. This looks like it is appropriate 63 seconds ago. Okay, so as will be traditional, I guess, sometimes I will just kind of struggle through the setup to this. So let's look at our question. I'm going to shrink myself down a little bit and throw myself over here. So we got two countries, Felicidad and Bellissima, making jeans and rye. Now, one of the little bits of frivolous extra layers of complexity that textbook authors will throw into these things is they'll add in an extra layer and say these countries have such and such amount of labor and they're doing all these things, and you're basically multiplying numbers that don't really matter that much. So let's get around that by just setting things up and focusing on what matters, and then we'll do that multiplication afterwards. So we've got F, we've got B, we've got jeans, we've got rye. Let's make these columns a little narrower so we can fit it all on a half page. So this is prod per production per hour. So 8, 32, 12, 24. And we can use this to calculate trade-offs. Now, strictly speaking, a cost is an opportunity cost, and an opportunity cost is the value foregone from your next best alternative. In this case, we're going to kind of butcher that definition. We're going to say it's not that you are giving up the benefits of some nice pumpernickel because you're making jeans instead of rye. We're just going to say you are giving up the opportunity to make some rye if you're making more jeans. So for each of these two countries or individuals or whatever, and for each of these two goods, we can say that the cost of 8 pairs of jeans is 32 bushels of rye. The cost of 1 pair of jeans is going to be 1/8 of that cost. So this is going to be, well, the cost of 8 is 32. The cost of 1 is 32 divided by 8. Right? So we're just going to say the amount of rye you can make divided by the amount of jeans you could produce. And we can copy this down and figure out the same thing for Bellissima. For them, every 12 units of jeans they make comes at the cost of 24 possible units of rye they could have been producing. So 1/12 of that is 1/12 of this, which is 2. And then by the same token, every time you make 32 units of rye, you're giving up 8 units of jeans, but per unit of rye, you're giving up 1/32 of that. And again, we can paste this down and we get each bushel of rye costs a half a pair of jeans for the people in Bellissima. And then we got all this nonsense about millions of hours of labor. So we got blah, 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 blah. Consequently, Felicidad produces 24 million pairs of jeans and 32 million bushels of rye, blah, 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 blah. But even easier than that, we can see Bellissima 1 million plus 3 million hours, 3 millions plus 1 million hours. So each country has access to 4 million hours of labor that they could be devoting towards genes or rye, right? So looking at this opportunity cost, now this is something that was sent to me by a student who had a clarifying question. So in this case, let's see if those numbers were correct. For Felicidad, 1 pair of jeans cost 2 bushels of rye. 1 pair of jeans for Felicidad, 1 pair of jeans cost 4. For Bellissima, 1 pair of jeans costs 2. All right, so let's try and make some indication of comparative advantage. Now, there is one context where a country does not have comparative advantage, and that's when they have the exact same trade-off as their partner. But in this case, these numbers are different, which means that someone has a lower cost for one of these goods. So we can just say, does comparative advantage exist? Let's start with the easier question. And that will be the case as long as this does not equal this. Let's see if Excel will deal with that. It won't. All right, so we could say it doesn't exist if this equals this, right, which is false. So it's not false that there exists comparative advantage. So let's change this to be not. So if it is not the case that B7 and B6 equal each other, then there is comparative advantage. And we can pull this over here. Now, if it's the case that we've got different numbers here, because of the setup of this problem, it's got to be the case that there are numbers over here. So then we can ask, who has comparative advantage? So then we can say equals if this, right? So if there is comparative advantage, then we're going to have something. So actually, let's do that. Let's add a layer here. So we'll say equals if this, then we'll put whatever we put in here. Otherwise, we will put nobody. Now, this, by the way, is not the only way to do this, but it is. There's many ways you can get to the same answer, is the point I'm trying to make. So I'm just kind of throwing myself at this, doing this ad hoc, and doing what comes to mind at any given point. This isn't the only way I've made this spreadsheet before, but it's all going to be logically equivalent. So let's see, that is 4 to 1. So if we made this 48, now they have the same trade-off, and now nobody has comparative advantage in genes or in rye. Let's use cell references just to make this a little nicer. So this is what? Wow. Genes. This was rye. This was Bellissima. And this was Felicidad. Something like that. I might have the spelling wrong, but they're made up countries, so no one's going to come after me. So, and then again, we'll say this is genes. And now we could even say, hey, we've actually solved more problems than just the question of genes and rye. We could say genes and computers. Right? We have solved, well, we haven't solved it yet, but we will have solved the problem for any 2 goods, for any 2 countries. It doesn't even matter that the people of Felicidad and Bellissima have wildly different beliefs and customs. Regardless of that, given these differences in trade-offs that we eliminated, given these differences in trade-offs when we put this back to 24, we have some comparative advantage. Now, the really cool thing we're going to be making with this is a spreadsheet that updates itself, which means that as we change these numbers, we should be getting the right things. All right, so what we want to do is we want to fill in, if there is comparative advantage, who has it for each good. And the answer is going to be whoever has the lower number, right? So bellissima for jeans, felicidad for rye. So we want this to turn into felicidad. So I'm going to use an if statement, and I'll say if this is less than this, then we will go with felicidad. Otherwise, we will go with bellissima. And let's take this, and is it a 4? 4, I think it is. Cool. Those dollar signs just mean it's easier for me to copy that cell over. So there is comparative advantage. It goes with bellissima. Now, again, if we change this to 48, the real answer is nobody has this. So our if statement here says bellissima because B6 is not less than B7. So B6 being less than B7 would imply it's bellissima. If that's not the case, that would imply felicidad. Sorry, it's easy to dyslex on this. So we could make this a little bit more elaborate. Strictly speaking, we need to have it less than or equal. Otherwise, we would check to see if the other country has it less than. Well, sorry, it should be less than, like we've got here. And then if it's not less than, strictly speaking, over here, we should check to see if B7 is less than B6. We could do that. So we could say if B7 is less than B6, then we could say $A, $6. Otherwise, we'd say nobody. And then let's again change this to, oh, no, it didn't work, did it? If B6 is less than B7, then if, okay. This is why it's a pain to do these nested statements, but now I'm invested. So we'll say if this is less than this, then felicidad has comparative advantage. Otherwise, if this, need the parenthesis, if this is less than this, then it's bellissima. And if that's not the case, then it must be that this isn't the case because we don't get into this cell, into this condition, unless this is not true. So here we could say nobody. Cool. And again, let's make these references that aren't going to get messed up. Copy this over. And now we can get rid of that. We can get rid of that. We have simplified this a little bit. So who has comparative advantage? For jeans, nobody. For rye, nobody, unless we change this back to the original thing, in which case bellissima and felicidad. And let's just drive the point home. If we increase this number, if we change it, then we can flip these two so that it goes the opposite direction. Right? So the nice thing about doing this in Excel is it's calculating everything for us automatically. Now, 157 students, I highly recommend making this Excel spreadsheet. But you're not going to be able to really take advantage of it on the midterm that's going to be coming up. I have to set that up, finish setting that up later today after this screencast. All right, so we have figured out who has comparative advantage. Let's go back to our question. Let that structure where we go next. So we got some opportunity costs, and like I said, it's not really the opportunity cost, but for this unit, we're going to pretend. Suppose they specialize in production of the good in which it has comparative advantage producing only that good. So, in this case, we can ask about production for our two countries. For our two goods. And we'll say if this, sorry, again with parentheses, if this equals this, so if Felicidad has comparative advantage in genes, then we will say they spend their 4 million hours of labor producing this many per day. Otherwise, I'm just going to put in a dummy 0 just for now. So let's see, if B10, we want to fix that. And actually, we want it to be, we don't want the $B, we want $10. There we go. So if B10, right, we let the column change, we'll see that in a second, but we keep the row as 10 with that $sign. If this cell is equal to this cell, which is Bellissima, so if Bellissima has comparative advantage in genes and we are looking in the Bellissima row, then our production is going to be 4 million units times that figure we got in B3. And let's see what happens if we just copy this straight across. No, that's not what we want. I know what happened. So let me show you. It's asking if this cell is equal to 0, when we really want to say, is it equal to B13, which means we want a $sign in this A. So if we take this, we can now paste it into each of these cells, and it updates correctly. So we're asking if the person with comparative advantage in rye is the country we're looking at right now. Beneath that, we say, is the country who has comparative advantage in rye the country we're looking at right now? The answer is no. In that case, they are not going to produce any rye. Cool. So we've got our production. So this is our production following comparative advantage, where they are producing what they have comparative advantage in, specializing entirely. Cool. Let me just really quickly respond to a student. I'm going to pull this over here, do this off camera. Where did it go? Ah, here we go. All right, that's fine. All right. I think I'm in here. Maybe I'm in here. Hey, Lola. Cool. Victoria, I don't know if you can hear me, but I am doing a comparative advantage question right now, just for the benefit of whoever's watching the YouTube channel. But I'll come back and do a binary example in a little bit. All right. I'm going to try. I have no idea. I think I might be muted. All right. Let me just make sure I do this. Okay. We'll do soon. Just finishing the comparative advantage example. Cool. All right. So we're saying suppose each country specializes and does this. So we got that. So now we can see our total production is going to be all these millions and all these millions. And you know what? It's actually kind of a pain. So let's just interpret these numbers as millions. So we'll just say times 4. And we'll say in millions. Millions of bushels, millions of pairs. That'll be fine. Cool. Cool, cool, cool. Don't totally know what I am doing, but that is fine. Here we go. So given this, 48 million compared to 128, that looks about right. Bellissima doing the genes, Felicidad doing the rye. And then, if we got this, let's zoom in better. Make sure that we can see that properly. So in the following table, enter each country's production decision on the third row. So we've got some production possibility, then we've got some trade. So we figured out what they're going to produce. We need to figure out what they're going to sell, and we need to figure out if that's going to be a good outcome. So let's think about a possible trade. So we're going to have, let's see, part one, what each country gives up. Actually, is that part one? It kind of implies part two. So we'll just call this trade, what each country gives up. Cool. Cool, cool, cool. Again, copy. Oh, never mind. This equals this. So let's just say they give up half their production, just to make up a number. So say this divided by 2. So Bellissima is giving up 24 million pairs of genes. Felicidad is giving up 64 million units of rye, 64 million bushels of rye. So then we can ask, is this a good thing? Are they going to be happy with this trade? And I think the simple way to figure that out is going to be, let's see, how do we want to figure this out? Is it a good trade? So from Bellissima's perspective, they basically want to ask, what is the opportunity cost of what they're giving up? So actually, let's put it this way. Days to produce units sold. Right, so let's just imagine they got 4 million hours of labor per day, right? It could be per year, then we call this years to produce, but whatever the case is. I'm going to be kind of lazy, not even bother looking this up. So days to produce units sold for Felicidad. Oh, not that. For Felicidad, the amount that they're giving up is 0, and we can compare that as a fraction of what they could produce in a year, which is going to be 4 million times their hourly production. If they'd spent all their time on genes, if they'd spent all their time on rye, there we go. This makes sense. So they're giving up half a day's production, right? We've set that up. So they're giving up 0.5 of a day, given that they've got 4 million units per day to apply to making genes. And then we can ask days to produce units received. This is really what's going to tell us if we're getting a good deal. So, from Felicidad's perspective, they're asking, what is this out of 4 million units of labor times this? Is that right? That looks right. So for Felicidad, they are getting 24 million pairs of genes, and for them to produce that, we can ask, how much could they produce in a day? They could produce 4 times 8 is 32. So they could produce 32 million pairs of genes. They're getting 24 million pairs of genes, so they're getting 3/4 of what they could produce. In terms of rye, I believe we just copy that across. It's 0 anyway, so it's not a big deal. And then here, we want to say bellissima, what they're getting, divided by 4 times. This is 4 bellissima comparing to what they can produce. There we go. Should be 0. Then we can ask, what is their outcome? Strictly, so there is a little gap I'm gonna leave in this model, which is if we were to mix this up a little bit, right? If we were to say you're giving up some genes and that. In this case, oh, actually, you know what? This is gonna be a pretty easy gap to fix, so I'm not even gonna do it. But the gap I was about to see is I was gonna ask, is this number bigger than this number? And if that's the case, then what they're getting is saving them 0.77 days at a cost of what they're giving up, which is 0.53 days, which actually is not a problem at all. So let's leave that as it is. So we can ask for each of these 2 countries. So this will be if the sum of these is less than the sum of what they are giving up, then they are going to be unhappy. Let's just put in a 0 really quick as a dummy spot. So here we have a good trade. If the sum of what they're getting is less than what they're giving up, then they're unhappy. If, on the other hand, that's not the case, and if, in fact, let me just do it this way, the sum of, let's just keep it in the same order, the sum of what they're getting is less than, sorry, is greater than the sum of B21 to B22. If that's the case, then they are going to be happy. And otherwise, they're going to be indifferent. Cool. I think that captures it for Felicidad. And then I think if we take that, or actually, sorry, I'm adding up in the wrong direction. So let's just do something a little bit simpler. So let's say total equals this plus this. That's a lot easier. So for Felicidad, and let me check real quick. There we go. All right, cool. Yep, nice. Back to Excel, cancel, don't close. Did I screw this up? Nope, still here. All right, so our outcome, the question is, are we coming out ahead on this? And the answer is going to depend on if we are getting more than we're giving up in terms of the time that it's taking. So what we get is Felicidad is happy if this number is bigger than this number. If that is the case, they are happy. If that's not the case, then we have to ask, is it the other way around? Is what they're getting less than what they're giving up? And if that's the case, then they are unhappy, and otherwise they're breaking even. They're not coming out any further ahead or behind. Boom, there we go. So this is a mutually beneficial trade. We set them up to go in their direction of comparative advantage, and we made a really simplifying assumption of we're just going to give you a half a day of our productivity for a half a day of your productivity. but there are any number of other possible trades we could make. So let's just make these explicit rather than being something based on what we started with. So we could say, well, what if we said 0 for 24? Well, in that case, Felicidad is happy because they're getting 24 pairs of genes, 24 million pairs of genes. But Bellissima's unhappy because they're giving up genes and getting not enough in return. Let's put in 24. Let's see, what should this be? I think 48 is where we start to get it. 47, 48. All right, at 48, Bellissima's breaking even, Felicidad is happy. And if Felicidad gives a little bit more, that's going to sweeten the deal, so Bellissima's now happy. And if we make this too big, 80, we're still fine. 90, we're fine. 100, it's too big. Felicidad is now giving up too much relative to what they're getting. They're giving up 78% of a day to save 75% of a day. All right, so that is the basic formula that checks that to see if this is a good outcome. And then in this case, I just said, whoops, not that, undo that. So we're just comparing what are you giving up, what are you getting, and we're just calculating that based on some trade. So we say if you're giving 100 or if we're giving 500, it's going to take you 4 days to make up that trade. But if you're getting 250, well, in that case, it's going to take 5 days. But from Felicidad's perspective, they're spending 4 days to save 8. From Bellissima's perspective, they're spending 5 days to save 5. They're breaking even. All right, let's leave that there so that I can go back into my office hours and address specific questions. I hope this was helpful for comparative advantage. And for 250 students, this is logic applied in Excel, so it's a little different than what we talk about in formal logic, what we're seeing in Khan Academy, but it's the same basic thing. We're asking for if conditions, we're asking nots, we're asking if something's bigger than something else, and based on that, we're saying if this condition is true, then update with this value, otherwise check this other thing. Cool, let's stop there.